Hello and welcome to the Unit 5 review. Today we're going to be graphing points, lines, and see what we've learned over the last unit. I don't want to take a lot of the points away from you. I think they're kind of more or less the same for every problem, so it doesn't really matter which one we do. We'll go ahead and do the first one together. So for point in G, it's at -7, 5. So if you remember, that's -7 on the x-axis and up to 5 on the y-axis. So you're going to get a point right there. It's G. Remember, the first coordinate is x, second coordinate is y. So that's just how we talk about locations on a coordinate plane. Let's look at the next section. Okay, we have a lot of different slope conversations. That was one of our sections in this unit. To find slope, remember you just want to go rise over run. Okay, I'm not going to actually figure it out for you. I want you to do it since there's only two problems there. Okay, let's look at the next section. In the next section, we're finding the slope of the line through the different pairs of points. And for that, you need to remember that m, the slope, is y2 minus y1 over x2 minus x1. And if you remember, the way we use that is say that we have our 2 points x1, y1 and x2, y2, and then plug them into that formula and reduce it, simplify it as much as we can. So y2 minus y1, so it's going to be -1 minus a -6 over x2, 20 minus 19. That's going to turn into plus -1 plus 6. That's going to be a +5. 20 minus 19 is 1, so our slope is 5. Okay, that's enough for that page. I don't want to take any work away from you guys, so let's go and turn to the next page. And on this page, we're going to be graphing equations. Okay, some are in point slope, some are in slope intercept, some are in standard form as well. So I'll just do one of each. These first ones are in point slope form. Let's look at number 14. So the point that we have is 2, -1. Or sorry, that turns in, each one of these is the opposite. So that's -2 and +1. So our point is 1, -2. Remember, we're looking for the opposites of those there. Okay, so at 1, -2. And our slope is 2/3, so up 2 over 3. Get our 2 points. If you have a ruler, please use it. Okay, don't let that thing go to waste. If you don't have a ruler, remember you can always fold up a piece of paper a couple times to give yourself a little thicker edge, and make sure we are graphing the line at least from edge of the graph to edge of the graph wherever it hits. Okay. All right, let's move down to the bottom. We'll do number 18. All right, slope intercept form. My intercept's -4 and a slope of -3. That would mean down 3 and over 1, but I can't do it. Okay, because I run out of room on the graph, so we'll go up 3 and left 1. Once you have your 2 points, you can do it again if you want to. I like to do it a couple times so that I know I can just get that much straighter and that much more descriptive of a line. And so now that we have our points, and make sure you continue that through the edge of the graph to keep me happy. All right. Showing effort is the main way to get points on graphing. So the top two on this page are also slope intercept form. All right, but down here we have standard form. And remember, for standard form, we want to find intercepts. If I can spell it right, find intercepts, and that's the cover-up method. So let's use that on number 24 here. If I cover up the y term, I get -4x equals 20. Divide by -4, and x equals -5. So the x-intercept is -5. Let's cover up the x term, and we get 5y equals 20. Divide by 5, and y equals 4. So that's right there. If I have my 2 points, I can graph my line. So one thing to remember is that even if you don't remember any of these methods, you can always plug numbers into a table. A table will always work. Input, output, and figure out what the points are. Okay. And the key here is that we're graphing lines, so we really only need 2 points. Let's take a look at the application problems. So here we have, we're learning dance stuff. We have a big dance that we're going to go to, and there's the Corey case and the Brittany case. So me and Brittany. I don't know any dance moves, but I learn 5 moves every 2 weeks. So what is the initial value? How many dance moves do I know at the start? What is the slope? Okay, how many moves do I learn over so much time? What does the slope mean? Okay, use it in a sentence with labels. And that's the specific slope. So whatever you find your slope to be, talk about what it means. Write an equation, graph the equation, and then predict. Okay. Same thing over here, just a little bit different. This is what is the y-intercept. Hint, hint, it means the same thing as the initial value. Okay. So that's really saying what is the initial value. What does that mean? Okay. Y-intercept means initial value. That's kind of the idea there. But use it with the dance moves that are apparent in this case of the problem. What is the rate of change? Again, that's just the slope, so figure out what that is. And write an equation to model it, graph the equation. So you're going to have both equations on this one graph, and you'll see kind of a comparison between what the person started with and what they can end with, and then what the other person started with and what they can end with. Okay? So in the second set of problems for this application, you're going to be using this graph over here. And I figure it's about candy cane time, so that's always kind of fun to work with. Especially now they're probably on sale. But Mr. Gull buys a box of candy canes, he eats them continuously. So just one candy cane after another, just shoving them down. So you want to find the slope of this line, find the y-intercept of this line. What does the y-intercept mean for this situation particularly? What is the x-intercept and what does it mean? Okay, so I want you guys to work on that. If you have any questions, feel free to ask, but I want to see if you can do it first and show me that you've at least thought about it before coming up and asking questions. Other than that, good luck on the test coming up, and welcome to term 2. Here we go.